Okay, so what we're going to do in this lesson is focus on sketching graphs of quadratic functions, and we're going to be sketching the graphs of the quadratic functions algebraically, which basically means without the use of the calculator. And so what we're going to be doing is using also a slightly different approach from what we did in the first lesson. We will not be using the minus b over 2a formula in order to find the axis of symmetry. Instead, what we're going to use is factoring combined with really the symmetry of the graph, which allows us to find the x-coordinate of the vertex or turning point. So just a quick reminder, this was an example that we solved in the previous lesson, and so as you can see, it is a solve equation. It was a solve equation where you needed to find x values, and what we did was we did this by factoring. X squared minus 6x plus 5 factors as x minus 1 times x minus 5, and that gave us x values of 1 or 5. Now those are the x values when y is 0, and so the original function is y is equal to x squared minus 6x plus 5. When y is 0, we find the two x values, and what those basically give us is the points at which this graph, which you can see is drawn on the axes below, cut the x-axis. And so 1, 0, y is 0, x is 1, 5, 0, y is 0, x is 5, and that gives us the points where the graph crosses the x-axis. Okay, and so what we're going to do now is use the fact that we know that parabolas are symmetric, which means if we can find the fold line, which is the axis of symmetry, officially referred to as the axis of symmetry, then we will know the x-coordinate of the vertex or turning point. And so if we picked any two points on the function which were mirror images of each other, and we worked out the midpoint of those, and so as you can see this point over here, if we go 1, 2, 3 blocks to the right, and from the point on the far branch we go 1, 2, 3 blocks to the left, then the point marked in the middle would be one of the points on the so-called fold line or axis of symmetry. And then if we scroll down and repeat that, you would see that if we found the midpoint between the two x-coordinates, that would occur, if you look at the values, at x equals 3, and that actually, if we draw a vertical line x equals 3, would cross or pass through the vertex, which in this case is a minimum, and so we know that it's a minimum because of the fact that the coefficient of the x squared term is positive. We now have the x-coordinate for the vertex, and in this case we have a graph, so it's very easy to read off that the y-coordinate would be minus 4, but the theory would be if we didn't have a graph and we were doing this algebraically, we would then substitute in y equals 3 squared minus 6 times 3 plus 5, which would give us 9 minus 18 plus 5, which would give us the minus 4, which is confirmed here graphically, and we would have the coordinates of the vertex or turning point, and that would be 3 minus 4. And so that's what we're going to do. Before we go ahead and do a graph, the intention is to start off by doing a little bit of practice, a little bit of revision on how to factor. And so keep in mind, when we're factoring, what we're really doing is treating y as if it was 0 in order to find the x-intercepts. So we're going to go ahead and factor the following trinomial. Factors of x squared are x and x. Factors of 3 are 3 and 1. Signs are the same. They are both positive. And in this case, we can go straight to our solution. X plus 3 multiplied by x plus 1. X squared plus 1x plus 3x gives us our plus 4x plus 3, and that would give us equation solutions of minus 3 or minus 1. in graphical terms, we would have x-intercepts of -3 or -1. And so we'll go and use the same approach for the second example. So in this case, once again, we are treating y as if it was 0 in order to find the x-intercepts. We are finding the factors of x squared are x and x, factors of 24, which will yield 5. And so we can test a couple of different pairings. We have 12 and 2, 8 and 3, 6 and 4, 24 and 1. If we look at the sign of 24, it's a negative, which indicates that the signs are going to be different. One will be a plus and one will be a minus, which, as you recall, means that we are subtracting these numbers here. And so if we subtract those, we will see that the one we want, or the pair of factors that we want, are 8 and 3. And we're going to come back in. We have 0 equals x and x, 8 and 3, and the last thing left to do is to figure out which one gets the plus and which one gets the minus. Since we need minus 5x, we'll have minus 8 plus 3, and then our final solutions for the equation would be x equals minus 3, and we'll squeeze that in here, x equals minus 3 or plus 8. Okay, and so we move to the third example, and in this case, same concept but just slightly more complicated by the fact that we have a lead coefficient with 2, and so this time we have factors of 2x squared are 2x and x, factors of 5, 5 and 1, and we need to try them both ways. We have the same signs, both minus, which simplifies it a little bit for us. And now the last thing we need to do is figure out which pair, pairing works the best. So we have minus 2 minus 5 will give us minus 7. That's not what we want. And so minus 10 minus 1 will give us the minus 11x that we're after. 0 is equal to 2x minus 1. And the other parenthesis x minus 5, resulting in x values of 1 over 2 or 5. Okay, and then the last one is also quadratic, but uses a different factoring technique. It is not a trinomial. As you can see, there are only 2 terms, but our approach will be quite similar. So we have 2x squared minus 8. First thing we want to do is equate to 0. What I'm going to do this time is take out our common factor, leaving us with x squared minus 4. And this, if you recall, factors as a difference of 2 squares, x minus 2, x plus 2, and therefore we have x values, or zeros, of plus and minus 2. This lead coefficient of 2 does not affect the answer, but as you will recall from the work that we've done so far, will simply have an effect on how wide the graph is, and in this case it will have a narrowing effect. Okay, so that's a very brief review of factoring, and what we're going to do now is have you go ahead and graph the function that is given over here. This time what you're going to do though is do not use your graphic display calculator. This is going to be on the non-calculator portion of the test, so you need to be able to do this manually. And the intention of this is to show you how to use the zeros. So again, avoid using the minus b over 2a formula. This will give you a nice alternative for that. Okay, and so what I'd like you to do at this point is to pause the video and go and attempt to graph these, find the turning point yourself, and once you've done that, then just start playing the video again to see how you did. So please go ahead and do that now. Okay, and so hopefully you have gone ahead and made an attempt at factoring this yourself, and hopefully this is what you managed to obtain. So the fact that it's f of x doesn't matter. What we're going to begin by doing is zeroing that, because we're interested in the x-intercepts. Our function is x squared minus 2x minus 8. In order to get x squared, we have x and x. Factors of 8, 8 and 1, 4 and 2. Signs will be different. So we're going to have 1 plus and 1 minus. And so that means we are subtracting. We have 8 minus 1 to give us 7. And we have 4 minus 2 to give us 2, which is what we're interested in. So those are the factors that we want. And we have 0 equal to x with 4 and x with 2. And the last piece is to figure out which one gets the plus and which one gets the minus. We need minus 2x in the middle. And so we'll say x minus 4 and x plus 2. And so we have x equal to 4 or minus 2 as our two x-intercepts. And so what we're going to do at this point is now use the symmetry of the graph. So if we graph our two x-intercepts, one of them at 4, one of them at minus 2. If we then count the distance between those, so we have 1, 2, 3, 4, 5, 6 blocks between, and so what that is going to mean for us is that 3 blocks between those two is going to be our axis of symmetry. And so what we'll do is sketch ourselves a line segment. I'm going to just sketch very quickly a line segment which will represent the axis of symmetry. For the graph, we know that that axis of symmetry is occurring at x equals 1, as you can see from the graph. We've got 2 other points, and the last thing that we need to do is to substitute that into the equation in order to find the corresponding y value for our vertex. And so we're going to find f of 1, subbing in the value x equals 1 in the place of x in order to find y. And this will give us 1 minus 2 minus 8, which is going to give us minus 9. And hopefully we've got space for that on our graph, only just. And so we have the coordinates 1 minus 9 as our turning point. We've got our axis of symmetry as x equals 1. We've got 2 points on the graph, and that will allow us to draw our sketch of the graph, which will look approximately like that. We also have, we could pick out from the equation relatively easily, and that is kind of shown from our graph, that we're also going to cut the y-axis at minus 8, because that would occur when x was 0, we would have the y-intercept, and so that would occur at minus 8. And what we've been able to do is, without the use of the calculator or without the use of the minus b over 2a formula, we've managed to sketch a graph of our parabola using factoring. Okay, and so make sure you copy down solutions to the examples, and then what you need to do is get yourself a textbook and get underway on doing some independent practice, not using your GDC, but using the factoring method and then averaging of the x-intercepts.